relation between AMU and MEV. We know that 1 AMU is equal to 1.66 into 10 to the power minus 27 kg, and 1 electron volt means 1.6 into 10 to the power minus 19 joule, and 1 million electron volt will be equal to 1.6 into 10 to the power minus 13 joule. Now, let's use Einstein mass energy equivalence relation to convert 1 AMU into energy. So E equal to mc square, here m is this much, 1.66 into 10 to the power minus 27 into c square. C is speed of light, which is 3 into 10 power 8 square. So this will become 1.66 into 9 into 10 to the power minus 27 plus 16. Now, to convert it into MeV, this will be in joule. We can divide it by this value. So this will become 1.66 into 9 into 10 to the power minus 11 divided by 1.6 into 10 to the power minus 13. So it will become 931 into 10 to the power, here in terms of million electron volt, it will not be 10 to the power, only 931 ME. So this is an important relation for exam. Generally, this question comes to convert 1 AMU into an EV. Now, another concept, nuclear size. So practically, it is found, or on the basis of certain observations, it is found that volume of nucleus is proportional to mass number A. So volume of nucleus is given by 4 by 3 pi r cube, where r is the radius, proportional to A, or r cube proportional to A, which gives r proportional to A power 1/3, which is further equal to r equal to r0 A power 1/3, where r0 is a constant whose value is 1.2 Fermi. R0 is equal to 1.2 Fermi. And if you remember, 1 Fermi equal to 10 power minus 15 meter. Now, let's see that nuclear density is independent of mass number. To prove nuclear density is independent of mass number. Let's see how. This is also one important question. So, if there are A nucleons and each nucleon has mass small m, then mass of nucleus equal to Ma. Now, volume of nucleus 4 by 3 pi r cube. And we know that r equal to r0 a power 1/3. So we put this value here. So 4 by 3 pi r0 cube a. Now density of nucleus, say it is rho, mass upon volume. Mass is ma divided by volume is 4 by 3 pi r0 cube times a. A will cancel out and we will get 3m divided by 4 pi r0 cube. Clearly, nuclear density is independent of mass number. Now, if we evaluate the value of nuclear density, so it is around 10 power 17 kg per meter cube. Now, let's see some more concepts. So, next point is nuclear force. Nuclear force is the force that acts between proton, proton, neutron, neutron, proton, neutron. So neutron, neutron. This force is attractive. Proton, neutron. This force is attractive. Proton, proton. Here also force is attractive. Although electrostatic force between neutron, neutron will not act, whereas in case of proton, proton, there will be repulsive force, but nuclear force will dominate. Hence, proton, proton will also attract. This force arises due to exchange of pi mesons that we will study later on. Now, let's see some properties of nuclear force. The strongest attractive force or the strongest interaction. If we compare gravitational force, electrostatic force, and nuclear force, so we will observe the ratio 1 is to 10 to the power 36 is to 10 to the power 38. So what do we observe? Nuclear force is the strongest. Second point is it is short range force. It acts in the range of 2 to 3 Fermi. If distance is increased in that case, this force will not act and electrostatic force will dominate. And next point is it is charge independent. As we have seen between proton proton or neutron proton or neutron neutron, it is always attractive. And it is non-central force. It means it does not act between the line joining the two centers, means the centers of the two charges, and this force depends on spin, means we can say that is spin dependent character. It means if two nucleons have parallel spins, in that case, suppose one nucleon has spin like this, another nucleon has also spin like this. In that case, this force will be strongest, and if the spin is anti-parallel, in that case, it will be the weakest. Thank you for watching.